The learning target for today, I can determine the method for solving a system of equations. So what you need to know, there are three methods to solving systems of equations. And really, if you like one method, you can stick with that method. So let's say you love substitution, you can do every system and solve it using substitution. You don't have to use graphing or elimination, or vice versa. If you have a graphing calculator or you like to graph and you like that visual, you can always graph to solve. However, I will warn you that sometimes if you have decimal answers or fractional answers, graphing can sometimes be a little bit messy in that regards, where substitution and elimination will give you very concrete algebraic answers. Now, when we are determining what method to use or what might be easiest. And when I say easiest, I mean really all that it means is that there's less steps to do to get to your answer. But again, if you don't want to use elimination, you don't have to. You could just use substitution, like I said. So when it's easiest to use substitution is when you have a y equals already given to you or you have an x equals already given to you. So if your equation is already isolated for one variable, that's when substitution is the easiest to use. I would say it's the best method in that scenario. Where elimination, if both of your equations are written in standard form, which look like this, where both variables are on one side of the equation, then elimination is going to be the easiest to solve for. So in the first example, here I've got negative 6x plus 5y equals 1, and then 6x plus 4y equals negative 10. Both of these equations are in standard form. I notice right away that my x's are going to eliminate really nicely for me because when I add them, they cancel. So elimination here is going to be the easiest method to use. Again, if you graphed it or if you use substitution, you're not wrong. It's just going to maybe take a little bit longer to do that. Second example, here I have negative 3x minus 3y equals 3, and then I have y equals negative 5x minus 17. So in this case, since I have this is already set equal to an isolated variable, y is equal to the rest, this is a great time to use substitution because that variable has already been isolated for me. Third example, I've got negative 4x minus 2y equals 14, and then negative 10x plus 7y equals negative 25. Now this one isn't quite as nice as the first two. I don't have anything that eliminates right away for me, but it's set up in standard form, so I could still use elimination pretty quickly just by multiplying the top or the bottom equation by some number to help eliminate variables. Lastly here we've got two equations, y equals 4x plus 3 and y equals negative x minus 2. This is a great time. Again, I've got my y's are already isolated for me, so using substitution here would be a great way to solve. Or these are both in slope-intercept form. Why not just graph both the lines and see where they intersect to find your solution? That would be another great way to solve this problem. All right, so if you want to take a minute and try your hand at what method you think would be best for these four, that would be a great time to pause, try it, and then come back and check. I'm going to walk through what I would use or what I think might be best for each of these scenarios. So the first one, I noticed that both of my equations are written in that standard form, the ax plus by equals c. So I would use elimination. B, second one here, y equals, they're both y equals. Whenever I have that variable already isolated for me, I'm going to use substitution. If I have a graphing tool, you could use the graphing tool as well. Third set of systems here, I noticed that my bottom equation, the x has already been isolated. Okay, so since that x has been isolated, using substitution here would be the quickest way to solve. Doesn't have to be your method. If you want to use elimination, by all means, you can go ahead and move that 2y to the other side so that you can eliminate. And then lastly, again, I've got both written in standard form. My x's and y's are all together on one side of the equation, and if you look here, my 3 y's are going to cancel for me right away. Super nice and easy to use elimination for that last example there. If you want some more practice on this topic, you can go ahead and check out that Learning Targets spreadsheet for additional resources, videos, and practice.